On to our second part of Module 9. So next, we want to use a two-dimensional, and you could actually have a multi-dimensional array. Now, do not confuse this with a parallel array. Remember using the parallel array where we had someone's first name and then last name and let's say their age in three separate arrays, but where you're just using the index or subscript number to keep all the zeros together, all the ones together, all the twos. Now, this is not that. So don't look at it and go, I think we've covered this. So we've up to now, everything has been one-dimensional or a single-dimensional array. And usually it's an array that you can picture as a column of values. You've seen me draw it out. Elements are accessed using a single subscript. So that's everything we've covered so far. Now let's head on to two-dimensional arrays. It has two or even more columns of values. It has rows and columns. Think of it as more like a table, if you remember, let's say from Word or Excel. And they're often called a matrix or a table, like we said. So if I were putting some numbers in a two-dimensional array that are integers, notice first I'm going to have two arrays to say this is a two-dimensional array. And we're basically going to say we're going to have three rows and four columns. Let me show that to you. So we have three rows and four columns here. So now we have this two-dimensional array that we can put all of these values in. And I know you're probably curious, why would we possibly do it this way? But let me just go over so far what we would say some numbers, sub 0, sub 0, some numbers, sub 0, sub 1. So this is a two-dimensional array in memory. And once again, the first number, how many rows, that means how many across, in this case, how many going across, how many columns, think of a big column of a building, is the second number. So we might put a dimensional like this. Now, let me set this up. I want you to imagine we have an apartment building. And for, let's say, studio apartments, we have $400 ones, $450 ones, and $510. You say, why are they different? Maybe the $510 has the better view. $400's on the ground floor and there's a lot of sound, and $450 is somewhere halfway up the building. These are studio apartments. Sorry. These might be one bedrooms, 500 in the basement, let's say, 560 in the middle, 630 up top. Maybe this is our two-bedroom rents. Decent, medium, and really great. And here is our three bedrooms. So the reason we're putting these in a two-dimensional array is because they work that way. These are the studios, one bedroom, two bedroom, three bedrooms, and we have three levels of rent. If we did them as separate entities, it looks like that these apartments have nothing in common. These three, now notice, we have a first curly brace and curly brace. And then this first row, if you would, these all have something in common, are together in a separate set of braces with a comma outside, a separate set of braces. By the way, these could all be on the same line. They probably just did it this way because they're running out of space. This is the second row, the third row, and the fourth row, if you would. And you pass array names just as you would do with a one-dimensional array. So just like we have in the past, when we pass them down, this is the receiving method. We would say, hey, it's an integer. It's got two-dimensional array, and here's its name, scores array. By the way, we would have passed it down as an argument, just as scores array from the calling function. Now, if you happen to use and need the length field, usually the length tells you how many elements are in the array. But in this case, if you just said rents for this one that we just had open, this one right here, and ask the question rents.length, it would hold the number of rows in the array. So in this case, if you remember way back here, there are 3 rows in the array. So that's what it would return. But if I said rents, and we put the sub1 there, dot length, each row has a length field and it holds the number of columns in the row. So this would come back with the number 4 because there are 4 columns in that, in row 1, let's say. So this is how to identify how many rows and how many columns. Now let's finally see a reason for using a 2-dimensional array, and I think this is a really good one. So I want you to imagine there is a company. Let me just say I work occasionally for Microsoft, and what Microsoft has are all these different departments, and then based on your years of experience, we actually have like tier 32, tier 46. It gets really complicated. So a lot of companies have these really kind of crazy pay scales. So I want everyone to look here. So this program is called Find Pay Rate. We're going to, the first row is for what we call the first department, the second department, third department, and fourth department. Although when we actually go to run this later on, we're going to call it 1, 2, 3, and 4. So can see it down here what's going to happen. I like that this program first shows what's going to look like. And then if you're just starting in Department 1, you'd start at $12.12 an hour. If you're starting out in Department 2, you'd get paid $13.35 an hour. You get the idea. If you're in your first or second year, this is how much you'd make in each of the departments. And 3 or more years, this is how much you would make. So let me show you the finished so it'll make sense what we're trying to do here. If I say I work in Department 3 and I've been 8 years on the job, so 3 or more, it's going to come back as $19.45. So now let's go look, and now does this double 2-dimensional array make more sense? So Department 1, 2, 3, and 4, 0 years is this entire column. 1 to 2 years is this second column, and 3 or more years is the third column. So now you kind of see why instead of putting them all on one line, we often kind of make them feel like a table, so we're not confused with what numbers go in there. So this assigned a string, department head of years, and the actual year values. We had int department and int years. So it says at first, this program determines pay based on the department and years of experience based on this table. And then we print these 2 lines out. And then to get the table basically, or the 2-dimensional array to print out, we're just going to do a very simple for loop. We're all for that, right? And here's the body of the loop in lines 24 through 27. It's going to start at 0, and it's going to keep on going while rates dot length. While it's still less. Now remember, rates are how many rows are there. So let's go look. There are 1, 2, 3, 4 rows. There are 3 columns. So this is going to go from 0 to 3 while 3 is less than 4. So we have a blank space. We put DPT, which is 0, 0 plus 1. It's going to put a 1 there. So what this is doing is on the outside of the outer loop, it's going to print out, the 1, 2, 3, 4. So line 24 is responsible for 1, 2, 3, 4 right there. Now this one does have an inner loop, lines 25, 26, and just 25 and 26. It's only got a single line. So this is going to go from years less than rate sub 0 dot length. Remember, this means how many columns. So we got rows, we got columns. So you can kind of see the outer is going to go through all the rows, the inner is going to go through all the columns. So this is going to print out rates. Now here's that 2-dimensional array finally in action in line 26. So first, it's going to do rates sub 0, sub 0. And if you were to draw this as a table, that's the value 12. So next, it's going to do, we're going to come back around to line 25. Years is going to go up 1. So now we're going to go 0 sub 1, row 0, column 1. So row 0, column 1 is 1341. So what this is doing is the outer loop prints the 1. The inner loop prints the 3 amounts on row 0. And then as we leave the inner loop in line 26, it prints a blank. It goes to the next line. So it comes over here. The outer loop now increments 1 up. It's now departments on 1. It prints the number 1 plus 1 is 2. So it prints that 2. And then years is now starting back over. Let's see. We had years here. We went through all the years. We're starting back over at 0. 0 is still less than the number. So now it's going through the numbers on row 1. Printing out 1335, 1467, and 1667. And blank line goes back again, prints row 3. Everything comes back around, prints row 4. So that's how we end up with these 4 rows, but how do we make it searchable? So after we basically get this loop from 22 to 28, to print out the little table for us. And that's going to help you print out lots of tables, so refer back to this. Line 29 finally is asking for some input. It's saying, hey, enter what workers department. And they know the departments by the numbers 1, 2, 3, and 4 from looking at the table. So that department is going to be assigned to department. And as you would suspect, we have to subtract 1 from it. Why? Well, department 1 is really row 0. Department 2 is really row 1. You know by now, right? And then it's going to say enter years of job, years on the job. So years is going to be how many actual years they've been. And so if their years is equal to 2 years, is equal to 2, years will become 1. You're like, what? Well, that's going to make you select this first column. If years is greater than or equal to 3, you're going to pick the second column. And years by default is set to 0. So if they put in 0, it'll do 0. You say, well, what happens if they pick 1? Well, it'll still go to the right column. Does that make sense? So that's the first column. So now, finally, this is the big payday. It says rates, whatever the department that they're in. So it knows whether they're 1, 2, 3, 4. We've already subtracted 1, so we now know what row it's in. And this, let's say we said we picked 8, so we know that's in the second column, 0, 1, 2. That's why it finds 1945. So look through this program. It's a little confusing at first, but I think you're starting to see this is a lot of value to use. I won't ask you to create one, but there are jagged arrays. That just means it has different rows or length. For example, maybe there's only 2 classifications of pay at a certain department, not 3. So it's possible, just so you know that. And there are multi-dimensional arrays. They can have arrays of any size. I know it's hard to think beyond 2 dimension, but it usually will it's a little too hard to, your computer's memory gets exhausted pretty quick from all of that. So be careful with any size. And there is an arrays class. And there is something called the binary search method. What that allows us to do is sort a list of values. And what these particular do, now I'm telling you, is this is a much quicker way to use sort, parallel sort, like 2 arrays at one time, than going through the bubble or the insertion. You say, now you tell us. So using these built-in methods could be pretty simple. I've just got a very simple program here. We are assigning to array int just a series of numbers, and clearly they're not in any particular order. So the array before sorting, if I put arrays to string and print it out, would be, of course, that same order. But this one little statement, arrays dot sort, this is, it goes out to that built-in class to take care of this, and it will automatically sort this from least to largest in this case. So yeah, the bubble sort is awesome, and I want you to understand how it works. But as you can see, there's some built-in ones as well. I want to show you this program for two different reasons. One, I love this little method at the bottom that's purpose is just to display again. So always like that. So it's just going to print what's in there. So let's start with the main method though at the top, and we have my scores. It's going to hold 5 different numbers from in the array from sub 0 to sub 4, just a single dimensional, one-dimensional array, no doubles this round. And if we wanted to display the original order, my scores, do you see this will just get passed down here as the string message. My scores, it'll pass, well, at this point, just this empty array down here. What will happen down here is it'll just show you that right now there's 0, 0, 0, 0, nothing in it is what's going to happen here. And then after it comes back, we're going to do arrays.fill. What fill is going to do is fill this array. This is one of those built-in methods. Arrays.fill is going to fill my scores, this empty array right now, with 8s. So it's just going to fill it all up. And then when we go down display to come down here, once again, it's going to print out the 5 8s. We're going to come back up here and it says after filling with 8s, my scores, we already did that. And now it's going to change. Don't forget it's 8, 8, 8, 8, but now it's going to do my score sub 2, which is the third value. It's going to be a 6. So after this line, it's 8, 8, 6, 8, 8. After then the next line, my score sub 4, it's going to change the last one to a 3. So 8, 8, 6, 8, 3. That's what it looks like. This display will come down here and print that all out very nicely. And oh, look at this one. This is the second reason I wanted to show you. Arrays.sort. So even though right now it's 8, 8, 6, 8, 3, it's going to change it to 3, 6, 8, 8, 8. So it's going to come down here, display how that's laid out. Kind of nifty. I really, just a real simple way. If you wanted to see things a lot happening in your array, nice little method. Well, one more here. I wanted to show you in this one. We haven't seen J option pane for a little bit, you know, the dialog box that opens. So we have the codes array, a character array with the letters B, E, K, M, P, and T. Don't forget single quotes because it's a single character. We're going to ask them to enter some kind of product code. So they're going to have that option of typing that in. And we're going to be able to grab that user's code, whatever the first thing they type in, char at sub 0. And then look at this, arrays dot binary search. Binary search is one of those built-in methods that can help you find what you're looking for. So here is our array called codes, you know, with those letters. And user code is what they typed in. If this second item is found inside the array anywhere, it's going to come back and give you a positive number. If the position is greater than or equal to 0, it's going to tell, in fact, not only a positive number, but what position is that number at. So let's say I type in the letter M as in Mary, and I'm going to see if M is somewhere in this. Well, not only will it find it in the binary search, it finds a particular position, 0, 1, 2, 3. So position would be 3. Is 3 greater than 0? Of course. So we get this little dialog box that says position of M. By the way, that should be user's code here as well. Notice that in the book they've made a little error, so it should be user's code all throughout. Is, and it'll come out with 3. If it doesn't find it, it wouldn't find any position number. So it would come down to this else and say it's an invalid code. So just a few of these that really help you find what you're looking for with the arrays class. Okay, I'll shut up and let you get started on your assignments. Take care.